Yes, I think we can get started now. Hi, good evening, everyone. I'm Karishna from the Tech Container team. Thanks a lot for joining us today. So, to give you a little bit of context about Tech Container, we've been using this platform to share knowledge on upcoming trends, with this being our 21st meetup. Now, moving on to the session plan for the day, to take us through Snowflake Data Warehouse 101 for developers, I take immense pleasure introducing our speaker, Dinesh Kumar. Our speaker, Dinesh, has 8+ years of experience around data. He is deeply involved in implementing B2B SaaS products for big data, ETL, and business intelligence. Currently, he's the product manager for the analytics and reports squad at Kissflow with GCP and Snowflake. Previously, while working at Syncfusion, he's worked with Microsoft Azure Stack. So, thanks a lot for being here, Dinesh. Over to you now.
Thank you, Karishma, for your introduction. So let's get started. And as Karishma told, I'm Dinesh Kumar. Right now, role playing as a product manager for the analytics squad in the company called Kissflow. So this is what our agenda is going to be. First of all, let me just crack what makes each scenarios, each data stack different. Database, data warehouse, and data lake, everything stores the data. But what is the crux that makes it different? That makes each of its each one of the category different. And then I'll talk about once after discussing about data warehouse, and then I'll move on to cloud data warehouse. So what is the magic that cloud data warehouse has brought, and why the world is moving towards cloud, by the way, to the cloud data warehouse as well. And I'll talk a little bit about Snowflake, why one should choose Snowflake as their cloud data warehouse choice, and a bit of concepts about Snowflake. One of its it's nothing but Snowpipe. And finally, I'll walk you through a demo where I'll be injecting the Twitter data into Snowflake with a near real-time fashion using Snowpipe. So that's what our agenda is going to be. By the way, I expect the crowd has some basic knowledge about database. So like what kind of basic knowledge is? They would have used any one of the database in their application. Either it could be SQL Server, or it could be PostgreSQL, or it could be MySQL, or any cloud data warehouse, or any big data, whatever it may be. I expect they would have used any of the database tool in their application or in their work pattern, right? So the session will be somewhat at the intermediate level, not at the very basic level, because we are the primary focus is to cover about cloud data warehouse. So the expectation is to the understanding about database and a little bit of data warehouse is what I expect. But anyway, if you don't understand anything, just stop me. I'll explain as simple as possible. So this the session is all about discussing and learning between each other. There is nothing that one is talking and the other is listening, and there is nothing that one person knows everything and the other person doesn't know anything. So everyone should be learning from other persons. That's what that is the policy I always have. So whatever the lame question it be, just stop me or just ask me the question when we have a Q&A time. Okay. So as a first section, let me demystify what a database is, data warehouse is, and the data lakes is, and in which scenario one the specific category is being chosen, right? So what do you think about this image? When we go to a hotel and from a variety of tiffin items, just we think that, okay, let's have dosa. Even in dosa, there will be a lot of items, right? The base thing will be same. It's going to be the same batter. But on top of that batter, some if we add cheese, then it becomes cheese dosa. If we add onion, then it becomes onion dosa, right? So similarly, database, the base category database is going to be same. On top of that, a specific unique thing gets added, a unique feature gets added that solves a specific problem. That is why in market there exist different databases, and all those databases are earning money, right? It's not that only SQL Server is winning, PostgreSQL is not at all there. Both of them serve their purpose, right? So I think this would be a better analogy, a basic analogy to understand. Whatever the scenario may be, whatever the variety of dosa may be, whatever the costliest dosa may be, sometimes as a person, we would be feeling to order just a plain dosa. I don't need paneer dosa, podi dosa, or whatever it may be. Just plain dosa is enough, right? That's what we will be feeling, right? So similarly, whatever the advanced latest technology comes in some cases, for some application, just a simple plain database would be enough, right? We need not think that, okay, what the latest tech will solve all the problems. The latest tech is the silver bullet that can solve all the problems. It's not the case, right? So that's where our maturity comes in. Okay, for this particular thing, this is enough. That's that the kind of decision making comes into picture when we have a detailed analysis of all what each database is about and what is the crux of each database. Fine. So first, let us talk about database. And I didn't added everything in this slide, right? So considering that, I understand people know about database, like PostgreSQL is a database, MySQL is a database, so SQL Server is a database that can be used to store the data and to retrieve the data for any application, right? So what is the main difference or the unique thing is for a database is the collocation of compute and storage will be same. What I mean here is there will be only one machine. Within that machine itself, the data will be getting stored, and also the compute, the processing speed also will be got from that machine itself. Consider that only one server. You can imagine your laptop. Within your laptop, if you are installing PostgreSQL, that PostgreSQL database software is going to use your hard disk to store the data. Similarly, that PostgreSQL software is going to use your laptop's RAM for computation. Computation here, I mean, the query we submit, select star from table, which means it will use the RAM space to compute that query and fetch the data, right? So database is nothing but in a single machine, in a single device, the storage and compute will be there. That's what the main point. And the other thing is schema on write. In a very layman term, in a database, we'll be able to store a data only after creating a table. Okay, that is, you need to create a table with a schema. Create a table with a name movie that should have movie ID, which is nothing but integer data type, and which is going to act as primary key, and movie name, which is string. Like that, you need to have the data definition language DDL query, and on top of the DDL only, you can able to insert the data. Okay, so that's the two main crux of database. So in my point of view, when the database can be recommended to use is if your application is going to produce a structured pattern of data, structured pattern in the sense rows and columns, that's almost less than a terabyte size only, then you can go for a database. Similarly, if the purpose is only for OLTP purpose, that is online transaction processing purpose, you're not going to perform any complex joins or complex aggregations on your data. You're just going to insert and retrieve. That's what, if that's what the basic purpose is, then you can definitely go for a database. Similarly, when a database is not recommended is when you have ad hoc analytics. Ad hoc analytics is nothing but your data is there and there is a problem statement, right? Consider that the data or your sales data is there in a database like PostgreSQL, and you have a scenario like you need to find the profit percentage of last 3 years in winter season of specific product. Okay, so to achieve this kind of ad hoc analytics requirement, you need to join multiple tables. You need to do a lot of aggregations. For that scenario, a database will incur a heavy compute, and it is not a best thing to play with. Perhaps, okay, there is a concept called cube. You can create a cube and then you can query on top of a database. But again, there the analytics need will be patternized, and that skeleton of cube will be created out of the database, right? So ad hoc analytics, if you have ad hoc analytics, then database will not be a right place to play with. And if you have more dependency in sharding, that is, if your data size is growing more, and as an architect, if you need to share the data between different machines, then database is not a right choice to go with, right? And is there any questions on this? Can I proceed?
I think you can proceed. Yeah, clear.
Okay, fine. Okay. So next, let me take it to data warehouse. Okay, so database was there. It is storing the data, and the compute and storage part is going to be present in same machine. Okay, and let's coming to the data warehouse. What happens is they have separated the compute and storage part. Okay, so what I mean here is you can store the data in a separate place, and you can use the compute resources from another software. Okay, so this is what a data warehouse's basic architecture mean. And by the same way, it is also going to be on a schema on write. To insert data into data warehouse, again you need to have a table created on the data warehouse, and only on top of that you can insert the data. Okay, so as you see in the diagram, at the center you could see the vendor compute. Just give me a minute, let me pick up the pointer. I don't get the pointer. Okay, anyway. Okay, so at the center, you could see a gray area, vendor compute. That is where what to say? It is nothing but the data warehouse. Okay, so from the source systems, the actual data will be coming into a data warehouse, and within the data warehouse, you will be having a virtual separation. Like for compute, you can separately scale it up for the compute. For the data storage, you can separately scale it up. For example, let me give a simple example. You have an application. That application's data size is, let's take it as 1 GB at the first year, and the compute is nothing but the number of queries. Let's imagine that the number of queries is about 50,000 queries is getting hit on the database. And the next year, the data size alone gets increased. The data size alone gets increased to 5 GB, whereas the number of queries is same. Let's imagine like that. It is same as previous year. It is 50,000 only. In this case, you can scale the storage part alone, and you need not to worry about choosing a big server that is having both huge storage and huge memory. Okay. Again, in a simple example, while we are choosing a laptop, what we think, okay, this is 1 TB of storage and 12 GB of RAM, right? And if we are opting to next configuration, then obviously it's going to be 2 TB of storage and let's say 16 GB of RAM, right? So the compute and storage scaling need not be together in a data warehouse. Okay, so you can scale it up, compute separately and storage separately. That's what the main crux is. And then you can go for a data warehouses. if you know the metadata, that is the schema of the data, the schema of the data is almost known, then we can go for the data warehouse. Schema here, I mean, is there is no unstructured data. You can mean like that, and there is going to be a structured data only, right? So that the columns, the number of columns in a table will not change frequently. If things are like that, then we can go for a data warehouse. Similarly, when you decide that ML or artificial intelligence, you're not going to play ML algorithms so much at this point of time, while starting point of time, then you can definitely go for a data warehouse. Okay, and also another main very important thing to choose a data warehouse is if you have a scenario to expose the data out, allowing customers to analyze. Okay, so that's where the data warehouses play a key role. All the data warehouses will be having a strong exposing pattern. What I mean here exposing is you can create simply a user, and you can assign a specific permission to that user or specific database, and that particular user can access that particular database alone. An external user, I'm not talking about internal company. The external users also will be able to securely access the data, right? That will be a little bit cumbersome when you go with database or data lake, but most of the data warehouses provide that feature inbuilt in a neat fashion. Okay, and when I'll not recommend the data warehouses, if your data is not at all a structured kind of thing, if the data you're going to analyze contains image and video, then I'll not recommend a data warehouse. Okay, so let me switch to the next thing. Nothing but data lake. So data lake, in a general term, what do you think a lake is? Just forget data and all everything. Just tell me what is meant by a lake.
A collection of water or something that stores water for some time.
Okay, so that's a good point. So where does that water comes in?
Any input, what we are getting, multiple streams, we may get the data. So
yes,
in that case, the large amount of data, we call it as a data lake.
Yes.
Mostly we'll get it
So,
from Kafka.
Yeah. So in general, if you consider a lake, for that lake, the water will be coming in different sources, right? Already some data will be some water will be present in that lake, and if there is some rain, then that rainwater will be slowly coming in and just getting dumped into the data lake like that. It is something like a still water, okay, which cannot be consumed directly from a lake. As a human, we won't be consuming the data, that water, right? We'll be taking the water and we'll be purifying it, and only then we'll be consuming that water, right? Similarly, in the application scenario, in our software scenario, a company could decide that, okay, let's store all this data for now, but let's do analysis on this later at a later point of time. Like that, there might be a situation. For example, consider Uber. They would be collecting all the trip information, each and every trip information, which route a user has traveled, and what kind of user is there, how did he paid, and what kind of the vehicle that user has traveled. All the data they'll be fetching up, and they'll be storing it in one place, either in a CSV file or JSON file, whatever it may be. But they won't be frequently analyzing the data. There will be another guy called a data scientist. That data scientist will pull all those, not all those data, the required data for his specific use case. Only those required data he'll pull out from the data lake, and he'll be using some system like Spark or a similar kind of ML engine and apply his requirement as a queries to get the insights, right? So in a simple scenario, again, the same concept is here: separation of compute and data. The data will be storing in a lake as it is, right? The data will not be disturbed at all, and the compute will be done only when there is some use cases. So when there is a huge use case, heavy compute will be incorporated. When there is a very small use case, a small compute will be incorporated. That is where the same analogy, separation of compute and data, and schema will be on read. Okay, so this is where the main difference between database, data warehouse, and data lake. Schema on read here. That is, your data will be dumped into data lake as it is, right? Only when it is being read, the schema will be created. For example, there is an ecosystem called Hive. Okay, in a data lake, the data will be stored as CSV file or JSON file, whatever it may be. While querying, the table will be created. Create table name with column 1, column 2, and column 3. And there will be another scenario. For example, let's in this example itself, you could see the two round rectangle box, Spark service and interactive SQL service. Let's imagine that there is a table with 100 columns. In that 100 columns, 1 to 50 is needed by data scientists, and 51 to 100 is needed by BA users. Okay, so in that case, while it's being queried, the data scientist will create another table with columns 1 to 50. Similarly, the BA user will create a table with columns 51 to 100. So this is what I mean schema on read. Whereas if you are in a data warehouse or database, it's always going to be schema on write. Whatever the table you are inserting, you need to create the table, only then you can insert. But in this case, it's reverse. You can just dump the data into a data lake. While querying alone, you can create a table. Okay. So when I'll be recommending is, if we have all varieties of data of any size, you have a structured data and you have a semi-structured data like semi-structured like an example XML or JSON, or you have an unstructured data like image, video. So if your scenario is being mixed up with different patterns of data, then definitely you can go with data lake. And another thing is, if you have a scenario like, okay, store now but analyze later, then definitely you can choose this. This is what I gave an example for Uber. And the next thing is, mostly this will be for the internal analytics only. As I told earlier, this is going to play for the internal analytics. External customers are not going to tamper with the data or use the data to use something. It's going to be for the internal analytics to improve the business or to improve the decision making and all those things, right? So for all these scenarios, data lakes is perfectly fine. When it is not recommended is, obviously, the data you store, if it is being needed for the analysis immediately, then data lake is not recommended. You can either go with the data warehouse, or if it is very small, then go with the database. Okay, so this is what the crux is going to be. So any questions?
No.
Okay.
Yeah, we can proceed.
Okay, fine. Okay, I'll come to so in whatever it may be, as of now we saw, in a real world scenario, there won't be just one specific category. In a big project, or even in a decent project, or within a company itself, there will be a database, a data warehouse, and there will be a data lake. All three will be present. For example, database will be used primarily for the applications OLTP purpose, right? For that application to perform, definitely a database will be there. And for that application's analytics needs, a data warehouse will be present. And for that company, for that software company to store different kinds of data, a data lake will be present. So by the way, there will always be a hybrid architecture, right? It's not going to be one specific thing, and that could solve all the problem, as I told earlier. So now let's come to cloud data warehouse. I hope what a data warehouse means you understood. So cloud data warehouse is nothing but it's something like software as a service. You can imagine like that, right? So you don't need to set up an data center. You don't need to install a software in that data center. Everything will be available in cloud. All you need to just to go and provision what kind of data warehouse you need, right? So in that space, there are four or five data warehouses, cloud data warehouses are there. I think I didn't added Azure Synapse Analytics, but somehow it's okay. So the very first thing is like a very first cloud data warehouse, which which was a kind of market leader was Amazon Redshift. Okay. So while Amazon Redshift was introduced, that was the only cloud data warehouse, and everybody and the specific requirement whoever had, all of them were opting to that. The main advantage of that is it has a very comprehensive security, and if a DevOps guy can tailor make Amazon Redshift, and he could secure as much as possible. And also Amazon Redshift is a little bit of little bit tied up closely with different ML engines. So if you have an ML use case, then Amazon Redshift would be a better choice. But what is the disadvantage of Amazon Redshift is the storage and compute were bundled in the sense not a closed type of bundle, but somewhat it was being bundled. Okay, it was like you will not be able to scale storage, or you will not be able to scale compute alone independently, right? So consider there are 3 tiers in Amazon, and tier 1, tier 2, and tier 3. So just a minute, I think I have an image, but anyway, okay, I think you'll be able to get the point. So tier 1 will be having 5 terabytes of data and 512 GB of RAM, and the next tier 2 is nothing but 10 terabytes of data and 1 TB of RAM. So like that, you can able to scale in a huge step only. You will not be able to scale with 2 GB increased RAM space alone. Like that, you will not be able to scale. That's what Amazon Redshift has was designed. And also there is a general talk that while the cleanup happens, the cleanup in the sense the computation it has consumed, it is not being released so quickly. So the computation will be running for some more time also. That increases to the billing cost, right? So this is what a simple explanation about Amazon Redshift. When it comes to Google BigQuery, obviously scaling is we need not worry at all. By the way, if you have an ALML use case, then it's definitely a good choice. But what the problem is, the pricing model is a little bit complicated, and one cannot derive what could be the pricing for so much compute easily. It will be a little bit complex to derive what is the pricing model of Google BigQuery. And all these analogies are just upon my own perspective, right? So it's just my thoughts. Let me just state that disclaimer as well. And when it comes to Snowflake, the main advantage is you can scale storage and compute independently, and it will be the performance is better than Redshift and Google BigQuery, and similarly the cleanup of resources is also better than Redshift. What is the main disadvantage of Snowflake is it is being just evolving in the market. So when it comes to mainly Google Cloud, just 3 regions are available throughout the world, right? Similarly, when it comes to AWS and Azure as well, the number of regions supported is somewhat limited than Redshift and Google BigQuery. So this is what the overall thing. Is it being able to follow, or how do you feel? You can even chat in the. Okay. Okay, thanks, Eugene.
What are
So
all those?
Yes.
Hello. Yeah, what are those 3 regions which Google Cloud supports currently?
2 regions in US and 1 region in Europe.
Okay, thanks.
Okay. Okay. So now let's jump into Snowflake Cloud Data Warehouse, and even I call it as a Snowflake Cloud data platform, because it is not just warehouse. It is providing more than the just the storage and the compute part of things. So I just call it as a platform. So for the same, let me switch to another slide. This belongs to Snowflake, and since it is good to like what to say, good to learn, I just chosen with the same slide itself. So the main paradigms is when it comes to a cloud data warehouse, when it comes to Snowflake, you can scale unlimitedly, and there is no strong barrier to scale only the storage or only the compute. You can scale independently, and you will be able to store both the structured and semi-structured data as well. And you'll be able to see while I show you the demo. The structured, I mean, is rows and columns. When it comes to semi-structured, it's nothing but JSON and XML type of files. And when it comes to the management, it will be very not we can't say very easy. The other way is to deploy a data warehouse. You would need a dedicated IT team, or you would need a dedicated database expert person, right? But when it comes to Snowflake, even a developer, upon reading the specific documentation and following up the options in the Snowflake user interface, he'll be able to deploy a data warehouse, and he'll be able to manage it very easily. You won't need an IT admin or a DevOps guy to manage this infra at all, right? So that's that's the level of simplicity it will be. Even in other case, I can give a simple example. Linux operating systems also there, but Windows is also there. Which one you would like?
Linux.
The other way, which one the business users are liking?
Windows.
Yeah. May I know why it is Windows? Why the business users are liking?
I mean, the UI is very easy. I mean, it's most familiar, I guess.
Exactly.
User interface.
The user interface is very easy, which both the business users also will be able to understand and use that particular piece of hardware and software, whereas developers also will be able to use, right? So that's how a Snowflake will be. You need not be a data expert. All you need is even if you are a full stack developer or a proper developer as well, you'll be able to follow with the Snowflake. You'll be able to spin up a Snowflake cluster. You'll be able to use it, and you will be able to destroy that as well. It will be so simple. That's what I mean. And obviously, it supports the ACID transactions and the SQL query. What to say? If you want to use Snowflake, you need not to learn another new language, right? If you just know the SQL language, then it is fine. Why I tell here is, when it comes to specific database systems like let's take Apache Hive, then you need to learn the HiveQL language. Similarly, when you need to use the Pig, right? It is also a big data software. Then you need to learn the Pig Latin language. But in case of Snowflake, you just need to know the SQL language alone, right? So already you would have queried with a database like PostgreSQL or SQL Server. With the same SQL language, you'll be able to work with the Snowflake as well, right? So let me just jump on to the next thing. I think, yeah, let's jump to architecture. So the traditional architectures will be something like there will be one shared disk and there will be one single cluster. That shared storage will be used by a single cluster. Similarly, there is a concept called shared nothing. The storage and the compute will be decentralized and there will be nothing shared. Okay. So when it comes to Snowflake, it is nothing but a multi-cluster and a shared data. For once, the data will be remaining here, and there different computation engine can happen over same data. Okay, I'll show this while I show a demo. It will be more clear. And by the way, the database will be sitting here. You will be you can design different compute set of compute for different use cases and people. For example, consider that this is nothing but the compute power, the RAM space, right? The finance team will be using a BI tool called Looker, and they'll be needing a small set of compute. Whereas a data science team will be there. They'll be deploying machine learning algorithms, and they'll be running many ML use cases. So they will be needing a large virtual compute. So having the data in one place, you can design different compute engines for different teams, and they'll be able to use separately. For example, if there is going to be only one compute, and all those compute is being used by data science team, obviously a finance team will not be able to use, right? There will be resource contention. But in this case of Snowflake design, there won't be any resource contention at all. And when it comes to virtual warehouse, this virtual warehouse is nothing but the compute. The virtual warehouse is a term being used by Snowflake. For example, you have a data system where you need to store the data, and that stored data need to be consumed by another team for analysis, right? So in that case, for ETL alone, ETL is nothing but extract, transform, and load. For this purpose alone, you can create a separate warehouse. For the transformation alone, you can separate a separate data warehouse. For the BI alone, for the BI, those who are querying the data, you can create a separate warehouse. So each thing will be acting simultaneously. For example, while the data is being inserted, the BI team will be able to query it. There won't be any resource contention at all. And the multi-cluster warehouse architecture is for whatever the number of queries it gets submitted, the query scheduler will be equally splitting up to and submitting it to different clusters. You can even think that this is what the big data environments are doing, but that will be a little bit of complex, because I have come across big data as well. So it is really complex to scale up a mission and scale down a mission. But in case of Snowflake, they have handled it very beautifully. Okay, I think this is the same explanation. I'll just skip. Okay, so the kind of storage pattern which Snowflake is following is they will do micro partitions. They will partition the data into small chunks, and they'll convert the data into columnar formats, and they'll store it as different partitions. Okay, so this is how the Snowflake will be storing the data. But while as a user on top of Snowflake, as a user, I'll not be able to see those partitions, columnar and all, but internally they are using such a kind of architecture. So I think this is all very advanced. So let me just skip here. Yeah, this is what the support I just told. So when it comes to Azure, okay, this is just an image, sample image. So you can have your data get stored in one particular region, and that can be replicated to another region. For example, from the US, you'll be able to replicate the data to Europe or Australia via a feature called global replication, right? What I mean here is you need not write an ETL script, or you need not write a SQL query, a long SQL script to enable this replication. By default, Snowflake itself will have a feature in UI and they'll be able to you will be able to enable this replication. So this kind of replication is very much important for big businesses. Those people would be expecting multiple copies of data get stored in multiple regions, right? Okay. I think it's good to go for demo as we have only 15 minutes of time. So far, any questions or anything odd? So how do you think? Or do you have any questions? Guys?
Dinesh, do we have another session where we can discuss elaborately on each topic as we go through the demo?
Yeah, I think I was about to tell that maybe you can comment in the meetup group itself. That meetup link, it's there now. So
okay.
Either Karishma or some other people who are organizing this, they could arrange one more session where we could pick up a specific thing and discuss it in detail.
Sure. I also have specific questions regarding like orchestrating a migration, orchestrating a Snowflake workload, stuff like that. So if specific, if those topics can be touched upon, that will be much more helpful, Dinesh.
Okay. Can you please elaborate your question? Orchestrating.
Okay. So let's assume we are
orchestrating. This is what you mean?
No. Just in case if we have a solution approach in Snowflake in place, okay, I kind of doing some self-learning for myself. So I just came through this concept of streams and tasks, okay, for this CDC, continuous data capture, okay.
Okay.
So in that, when it comes, I think it's kind of a little too deep now at this stage. But however, I would just like to bring up this point to see how we can automate or orchestrate the continuous data pipeline using inbuilt Snowflake functionalities, or just in case if an organization specifies the need to use Python or any other external scripting to access Snowflake and then trigger this streams and tasks, then how we could achieve that. So these two scenarios I would like to touch upon actually a little bit.
Okay. I'll just take 2 minutes and explain it with a very simple example. Okay, let's imagine that we have a source system. It is storing the data in a JSON format in a specific storage. Let's consider it as a MongoDB or some S3 bucket or something. And you are having a Snowflake data warehouse. So the goal is that streaming data has to be stored in Snowflake, right?
Correct.
Yeah.
And then it has to be also consumed by the downstream visualization or reporting platforms.
Yes, of course. Once you store in a Snowflake, then it's going to be accessible for
Correct.
So let me just touch upon main concepts alone. We can talk in detail later, or you can get me in touch with LinkedIn. So we just consider that we are using stream. What you can do with the stream is you can capture the change data alone, and what the Snowflake stream will do is that change data alone, it will be what to say, it will capture it and it will be converting it in a format that will be ready for query. Okay, so from the source system, consider that in Snowflake already there is a table and 1 lakh rows are there, and from the source system newly 100 rows are coming. If you enable a stream, that stream will capture that 100 rows alone, and it will be convert it in a format ready for the query, right? Next, you have two options. Either you can use task or you can use Snowpipe. If you are using task, then you need to capture that staged data, which was captured by stream. You need to capture that staged data. You need to execute a stored procedure. That is what the task in Snowflake, right? You need to execute the stored that task in a specific time, and you need to insert that data into Snowflake. To do this, it is enough to write the SQL statements within the task. Okay. When it comes to somewhat advanced thing, definitely you would be needing Python or C# or whatever the next level of coding needed. The other option is you have the data, you have the staged data that is being captured by stream. You can enable Snowpipe. That Snowpipe will automatically understand that okay, new data has come in, and it will act something like a continuous data ingestion, and it will do the respective transformation. I mean, not by itself. We should be telling that what kind of transformation it should do, and it will do the transformation and it will insert into Snowflake. So these are the two options. Via stream, you are capturing the changed data CDC, and either you need to use task or you need to use Snowpipe. Okay.
Okay, but Snowpipe will be daily. You will be extensively using it if we need to directly point to external cloud source and pull up any files that arrive in the storage, right? That is the primary use case for the Snowpipe, right?
That's what. You can say something things like it is automatically what to say, continuous data ingestion kind of thing. When it comes to task, you need to execute the task to fetch the data and insert. When it comes to Snowpipe, it will automatically fetch the data and insert.
Correct.
That's what. That's
correct.
It.
Correct.
So either it's going to be an S3 bucket or whatever it may be. If you need near real time, you need to choose Snowpipe. Or if you need once in a day or twice in a day,
scheduled one,
then you can go with the task.
Got it. Like a delta, we can go for a task.
Exactly. It depends on the SLA that application is being. Either you need real time or
correct,
you need
Got it. I just probably we can connect another time, in another opportunity to discuss probably how we can activate or probably enable these tasks to consume the changed data and load into the data warehouse. Okay.
Sure.
Thank you, Dinesh.
Yeah. Welcome. So upon this demo, I think you are able to see the image. Let me zoom it up a bit. I think it would take 15 minutes or 10 minutes after 6 as well. Let's see. Yeah. So what I'm going to do is I'm going to capture the Twitter tweets data via an event listener that will be pushed into a storage bucket. And from that storage bucket, from an event queue, I'll be pushing the data via Snowpipe into Snowflake. Within Snowflake, it will be in a staged table, and then it will be in a table. And for the visualization purpose, I'll be creating it as a view. Okay, so this table will be containing JSON data, which cannot be directly used by BI tools. So I'll be creating a virtual view on top of it, and via not Power BI. I'm not sure we have time. So just consider that some BI tool is consuming, right? So this scenario, this yellow color box, whichever the cloud it may be, either it could be Google Cloud or Azure or AWS, the specific services you need to use. For example, when it's AWS, it's going to be S3 and simple queue service, SQS. When it's Azure, it's going to be Azure Data Lake or Azure Blob, and it's going to be Event Grid. Similarly, when it's going to be Google Cloud, it's going to be Google Cloud Bucket, and I think it's Google Data Pipeline or something. Sorry, I just forgot the name. So whatever the cloud may be, the analogy, the basic idea is this, and based on your tech stack, you can replace it with whatever you have. For today's demo, I'm going to use AWS as the cloud provider, and let's jump into the demo. So this is the Snowflake interface. I think it will be very small. Let me try to zoom in a bit. Is this okay now? Yeah, is this visible? I mean, able to see the screen?
Yes. Okay,
fine. So this is the Snowflake interface. Okay, So since, as I told, it's a cloud data warehouse, it is not sitting in my Mac machine. Okay, it is not sitting in my Windows machine. Well, in the cloud, I have created a tenant, and this is the tenant ID, and I'm just using this piece of software. So I don't know what kind of what specific hardware is being used behind it. It is Intel or HP. I don't know. I don't know. Or in other words, I don't care. All I need is the work to be done, right? So it will be very skeptical, but just imagine your specific or your convenient database tool. You would have used SQL Server Management Studio, where it will be when you click something, the database will be listing. In a specific place, you'll be writing SQL queries, and in a specific place, the result will be shown, right? So the same, like just like that, imagine like that. Okay, so this also has a user interface. When you click database, it will be showing the database, and when you click warehouse, you'll be showing the warehouse. And when you click worksheets, this is where you will be writing the scripts. And this is the main thing you need to understand. There are two things, database and warehouse, right? So database is nothing but you will be creating a database, and that will be for the storage purpose, right? You will be creating a warehouse that will be for the compute purpose. That is totally isolated, as you can see in this particular point of time itself, right? Just be comfortable as of now with this Snowflake interface. Let me try to explain one by one, right? So there are specific things like roles and all. Just cope up with that. So Dinesh Kumar P is a user, and I have been in a role called sysadmin. Okay, sysadmin role will be able to write queries. He'll be able to create warehouses, and he'll be able to create databases and all those things. Whereas public will be the most lesser privileged role with very, very limited privilege. Similarly, like this, you will be also able to create additional roles, and you will be also able to create additional users as well, right? So for this demo, let me just switch to account admin, which is the highest privileged role, where I'll be able to having all the privileges. Okay. Okay, I think I lost the worksheets. No problem. Okay, it's getting loaded. Okay. Okay, so first what I'm going to do is I'm going to create database and warehouse for my specific use case, right? So as you see here, these are all default database, and I don't have any database to store the Twitter's data. Similarly, I don't have any specific warehouse for the computation. Just ignore this. This is default compute. Okay, where it is? Yeah, worksheets. So let me execute the SQL command one by one. So I'm switching to the role as sysadmin, and I'm going to switch, create a new warehouse called Twitter warehouse, which is going to be the size of X small. Sizing of warehouse also will be very, very simple, guys, in Snowflake. It is about X small, small, medium, large, X large, like the t-shirt sizing. You will be able to decide very easily. That's what I mean. And auto suspend, auto resume. Okay, it could be a bit advanced. So let me just create a warehouse for my computer alone. So warehouse is created. So if I go to my warehouse, I'll be able to see a new warehouse is being created, right? Let me go back to worksheets, and let me create a database. So once I refresh here, I'll be able to see the database Twitter DB. And I'm going to create a schema called, use the schema known as public. Schema, nothing but a virtual separation of tables within a database. So now I'm going to create a stage. So stage is nothing but, to simply understand, before storing data into Snowflake table, you need to stage it. That is, imagine that your data is residing in this particular storage bucket. this is AWS console, and this is my S3 bucket, my editor bucket, Dinesh. So from this bucket, you need to create a stage layer, a virtual layer. From that virtual layer, we'll be copying the data into the actual table, right? So for now, let me just create the stage alone. So the stage is created. Let me check whether the stage is created or not. Yes, it's been created. Name is tweets, and the database in which I created the data stage is TwitterDB, as you see here. And let me create a table. And as you could see, it is going to be having only one column. It is just going to have only one column with a data type called variant. Variant is just another data type like string, integer, datetime. Variant is a data type that belongs to Snowflake, in which you'll be able to store different formats of data, JSON, XML, or even a plain text, whatever it may be. So to store different formats of data, Snowflake has a data type called variant. So let us create a table. So let me open up the database and let me check whether I have a database. Yeah, table. So I have a tweets table, and it's nothing but having only one column, and there is no rows at all, right? Let me minimize a bit. I think the UI is breaking, and I think it should be easy to follow. So I have created a table. Now let me create a pipe. Okay. A few minutes back, I just explained to that's the question, right? To inject the data from one place to another, we need to either use task or pipe. In this case, I'm using pipe, so that whenever the new tweets are being collected in the S3 bucket, that will be collected and stored into a Snowflake in a near real-time fashion, right? So let me create the pipe. Yes, the pipe is created, and let me just check whether the pipe is present. Yes, I have the pipe. So at this point, let me quickly jump on to my S3 bucket, and I need to do a small step. So I have a pipe, but I need to I need to make my S3 bucket know that, see, this is the Snowpipe, and into the Snowpipe only you need to tell that the new data has arrived, right? So let me copy this data. Okay, I think let me show to you as well. Just give me a second. So from this Snowpipe, I need this notification channel value. Okay, so this notification channel value is nothing but, I think, this one. Yes. So this is the value I need. So I'm copying that, going to my S3 console, navigating to my bucket. So sorry, S3 bucket. In this S3 bucket, let me go to property section. And in that property section, I need to update my event notification. Only then the Snowflake will understand that, okay, new data has arrived. What happens is, once I have did this, the S3 bucket will indicate Snowpipe that, see, the new data has come. Like that, it will indicate, so that the Snowpipe will trigger itself automatically and inject the data into Snowflake table. So let me edit that. I have already I already have this notification channel value, which is, I just tried it out. So I just replaced it with the new value. Let me save it. Okay, I have saved. And next, what I'm going to do is to capture the tweets from the Twitter. I have just created deployed it as a Docker image, and let me just start that container. And before that, let's see. Till what data it is being present, so that we can, okay. today the date is June 3. Okay, I think it should generate another what to say. Okay, it should generate a month for June. Yeah, it should generate a month for 6, and it should inject data once I start this container. Let's see. Yeah, so we have the data, and for the time purpose, let me stop my container because the data fetch limit is very minimal for the free account, for the free developer account. What happened? Yeah, it stopped. So I think you got the point, right? So previously we had only this folder, and this folder was not there. It is nothing but June month, and in June month, the date 3, and in day 3, I have 2 set of files with data. Let us quickly preview this data. I think I will not be able to preview. Okay, I don't even able to open it. Sorry, this. So this is what the data is going to be. It's purely what to say, semi-structured. I don't even see where this particular row ends. That much complicated structure it is having. It is a JSON data, right? So JSON data, it is having a set of columns, and it is having some values. Now let's go to Snowflake and let's see whether we had some data within the tweets table. Okay, let's check that. So once again, we are already in this row system in the system called sorry, in the role called sysadmin. But I need to execute again because for a specific worksheet, I'll be able to have different roles as well. So let me use the warehouse, Twitter warehouse, and use the schema Twitter DB, and let me list the tweets that I have received. See, I think you're able to get it. So at Twitter db.public.tweets is nothing but the stage thing. So when you mention at, it will be pointing to the stage. Even I'll be able to show here when I select the database, and if you go to the stages, you'll be able to see the stage, right? So it is pointing to my Twitter bucket location, and okay, the main thing is both the table name and stage name is same, so you would be confusing, I think. But anyway, you can imagine, you can think like this: if you are using at symbol before the specific entity, then you are pointing a stage, right? So what let me do is from this thing I'm going. So you're able to see the rows. In the previous command, it is just listing. So this is in the first stage, for this particular size of data, this particular data is received. For this stage, this particular data size is received, like that. But you are not able to see the data when you're directly querying. To see the particular data, you need to query like this. Just take the first column alone and just fetch me the top 10 rows alone. The same thing which you are checking, I just showed in the which the other window, the Twitter data, the JSON payload, right? Okay, so now let me ask it to show the pipe, and let me just check the pipe's status as well. So now the main ball game, we are going to search the tables, the table, tweet table. Yeah, so we have 300 rows been injected into tweets table. Even till now, till this 5 minutes or 10 minutes, 10,000 or 20,000 rows would have been inserted, but I think it's not needed as it is for demo purpose. That's why I just stopped the Docker container. So let me just open up and see the top 100 rows. Yes, my table is having top 100 rows, but as you all know, you will not be able to directly analyze the data, this data, right? Because there is a first level of column is there, and there is second level column, and again there is third level column. It will be very difficult to analyze this data. So what we can do is we will be able to create a view in Snowflake. Okay, so this view is nothing but I think you all know about view. It is a virtual layer that sits on top of a table, right? So by creating view, you are able to query a JSON data, not even a flat structured data. You are able to query a JSON data as well. Like you are mentioning a specific column, tweet from this tweet table, from this keyword column, make it as a, consider it as a string data type, and name the column as keyword. From this tweet table, from the next level, created a column, consider it as a timestamp data type, and consider it as this column name, right? Let me just run this view command. Yes, my view has been created. Now let us see how many rows are there. Yes, I have 300 rows. Now let us view the view, check out what rows is there. See, now we have a clear view of rows, right? Earlier, the actual data that has stepped into the tweets table is of JSON type, and now I'm having the same data payload in a row and column type, right? You will not be able to you will not be able to query a JSON data easily, but in Snowflake you will be able to create a view, and you are able to have a structured data. There is no ETL, there is nothing. Just you are creating a view and you are doing it, right? This is a very big pain point. Those who have worked with data engineers and all those things, they will understand. Creating, converting a JSON data in an analytics ready format is a very, very painful thing. So that thing, I think Snowflake has cracked very beautifully with this pattern. So what let me do now is, do we have time? Yeah, we have, let's take 5 more minutes of time. And once again, let me open up the architecture diagram. We have Twitter data, and via an event listener, this is where the Docker, via the Docker, I have a Python script running that continuously listen from the Twitter for the specific keyword. It has fetched the data, and that event listener will be pushing the data and storing it in the AWS S3 bucket. That S3 bucket via SQS, it will be pushing the notification, and that notification will be triggered by the Snowpipe, and that Snowpipe will fetch the data from that event queue, from that storage bucket via a staged table, and it will be stored into Snowflake as a Twitter table. This particular Twitter table is nothing but having only one column, which is nothing but having the that JSON payload. For one row, it will be just one JSON. And we have created another another view that will be having as a different columns, right? That will be structured. That semi-structured JSON row has been transformed, so not transformed, that has been converted to be visualized as a different columns ready for analytics, right? So what let me do is, since this is Mac machine, I'll not be able to show a demo with Power BI. So now let me use another BI tool called Zoho Analytics. somebody would know it as a Zoho reports tool. So from that Zoho reports tool, let me connect this view, and let me quickly create 1 or 2 widgets. Okay, so this is my BI tool. From this, let me navigate to the data sources. And here, let me add a new data source, which is nothing but Snowflake. And here, I just need to give the account name, right? So account name is nothing but this one. Username, it's Dinesh Kumar P, and password, let me enter. Warehouse, I think it is Twitter _ warehouse, right? Yeah, for us. By the way, let me even show here. So we have created Twitter _ warehouse specifically for what to say, for the data ingestion, right? The data ingestion and the ETL part. Now let me create another warehouse for the BI reporting alone. We don't need so big, so let me just choose a small warehouse, and I can specify maximum cluster and minimum cluster. This particular configuration is for auto scaling. When you have, for example, let me just think that I have configured 7. When you have so many number of queries, right? So many number of requests like 10,000 or 20,000, automatically the warehouse will the warehouse count will increase from 1 warehouse to 7 warehouse, and once the incoming request has reduced just to 100 or 10, this 7 warehouse will get reduced to 1 warehouse, right? So there is no DevOps person sitting inside and switching up, or there is no infra person sitting to spin up additional servers at all. It all happens in a second, right? So for the maximum clusters for this demo purpose, let me choose as 2, and for at this moment it is enough with this explanation, I hope. So I have a warehouse ready for BI reporting alone. So let me just give this name, BI _ reporting, BI _ reporting. Okay, fine. So what I'm going to do is let me check the database name, and we need to give the database name. What is the database name? Cleats. Okay. So after giving all these entities, as usual, it will check for the valid password. It will do the authentication and also do the authorization as well. For example, even I may create a new user. Let's take Vishwa as an example. The data source doesn't hold any table. Okay, I think there is some issue. There is a table, then why it is showing like this? Okay, the database name is tweets _ DB. Oh my god, what happened? Data source specific doesn't hold anything. I think there is some permission issue because I'm sorry guys, something wrong. Either it should be with the username or there could be some permission issues.
We can try and query that particular database and table using that warehouse, right? See if there is a permission issue there in Snowflake worksheet.
We were doing that here only, right? So
Correct.
that warehouse is being used. Twitter underscore warehouse.
Right.
Okay, yeah.
No, but how about that new warehouse that we created?
Yeah. Let me. I think sysadmin is not having the privilege. That's why the warehouse is not working. Let me try to refresh the page and check. Yeah, that's the problem. So what we need to do is, okay, what can be done? Default role is sysadmin. I'm not able to change the role. Super. So what I should do is, let me create a user. Default warehouse. I think it's BI underscore reporting. Default role, account admin. Let me check once again. BI underscore reporting. Okay. Warehouse is BI underscore reporting. Even I don't need to give the warehouse. Fine with the role. Let me give finish. Now I have a user called BI underscore user. Let us quickly log in and see what BI underscore user is having. So as you see here, while I'm entering as a new user into the portal, it is asking me to change the password.
Hello, I can't hear anyone.
Even me, I think Dinesh is out of the connection. Oh.
Yeah, I'll try reaching out to him.
Oh, Dinesh, we can't hear you. We can't hear you.
Hello, Karishma?
Yeah, we can hear you now. Yeah.
Oh, okay, okay. I'm sorry. Internet. I lost the internet. Okay, where was we? Yeah. So let me create the connection again. I just connected to my mobile network, so there might be slow connection as well. Bear with that. Guys, do you remember what is the warehouse name?
BI reporting.
BI reporting, BI underscore reporting.
Yeah. Yeah. Now I'm able to see this. And so what this BI tool is showing me is all the tables which are privileged to this user. It is asking me which particular table you need to analyze, right? So as this is going to be tweets underscore BI, let me just choose that. I think that is the view which we are having. Tweets underscore BI, yes, right. So I have selected tweets underscore BI, and now let me select next. And I have all the columns listed here. I can select whatever columns I need, but however, what let me do is, okay, let's see. I didn't do any additional configurations. So it is just saying that what happened. Yeah, it has started importing the data from Snowflake's Twitter underscore database, and it is just telling that I need to wait for some time. As you could see, the sync is being progressed. Now what happens is the next level. From this Snowflake data warehouse, the data is getting imported to the BI tool, right? For the analysis purpose. The sync is being in progress. By the way, let me create a report on top of tweets BI table. And obviously there is no data, that is why it's showing empty. But to say, this is how it will be. It will take some time Let us see how much it has progressed. Yeah, it is a free edition, so it is taking some time. But for your sample, this is how it will be. Once the sync is success, you'll be having something like this, and you should be able to create new table on top of that. Okay, I'm sorry. You should be able to create new report on top of that particular table. For example, let me just choose this table. It will be displayed in this fashion, in a tabular fashion. Likewise, you'll be able to create as many types of reports based on your use case. You can create a chart view or pivot view. You can create aggregation fields or simply a tabular column. So this is how it would be. And I think I'm done. If you have any other questions, I'm happy to answer. And yeah, one more thing. So there is another concept that is coming up now, which is nothing but data lakehouse. And I don't think like Snowflake gets fit into data warehouse. Under data lakehouse, there will not be any new softwares will be coming in. What will happen is the data warehouse or the data lake will be evolving it as a data lakehouse, right? For example, Snowflake itself, they might brand themselves as a data lakehouse at a later point of time with the features that are specific to data lakehouse. Okay, so it is nothing but there are specific features, there are advantages in data lake, and there are specific advantages in data warehouse. Data lakehouse is it's going to string together both the worlds, and it's going to be one single system for structured, semi-structured, and unstructured. As of now, as I told earlier, in data warehouse, you'll be able to query structured or semi-structured data, but not unstructured. What data lakehouse will be is nothing but you will be able to query structured, semi-structured, and unstructured in a more better performant manner, right? So it's coming up. We can just consider like that. And I'm very thankful to Karishma for providing this opportunity and for the attendees to patiently attending all this time. Yep, thank you.
If there are any questions, you can ask away. Otherwise, we can wrap up.
Dinesh, is Snowflake fully equipped with processing the data from Kinesis streams? Anything like live streams, capturing data from them and processing them into the warehouse? Is that fully equipped now, or is it still in the development phase?
If you ask Snowflake, then they'll definitely tell it is yes. But what I prefer is, if it is going to be real time and the ETL is going to be costlier, then design that portion alone with a different system. Just connect with Kinesis with Spark and do the ETL there. And from Spark, use a system like Kafka and inject the data into Snowflake. That would be the best option, which I prefer.
Okay.
Okay.
Yeah, okay then.
So if you don't have any questions.
Yeah, thanks a lot, Dinesh. And for everyone who joined us today, I really hope you enjoyed it as well. Thank you so much. We'll be uploading this on our YouTube channel as well. And if any of you is interested in sort of giving a session on any technology, you can feel free to reach out to me. Thank you.
Sure. Thank you.
Thank you.
Thanks, Dinesh. Thanks, Karishma. Thanks, everyone.
Thank you. Bye.
Thanks, Dinesh.